So good morning students, we will now simulate the SRAM cell using MIcrowind software. So we will go to the palette and click on the NMOS generator, select NMOS, we will place over here. Now we will take one PMOS, again click on generate device and we will place over here. Now using stretch and move, we will align both the MOSFET. Okay. Using now, we will connect the gate terminal of both the MOS together. Again, we have to using metal one. We will connect the drain terminal of both the MOSFET together. This is the one in inverter. Now, for the SRAM, we will need two inverters. Okay. So what we will do? We will just click on the copy, and we will copy this circuit. Okay. Again, to avoid the floating, we have to apply VDD supply to both the way. Again, I have taken one VDD and apply on this. Now, if you see the circuit, what we need, we have to apply the output of the first as the input to the second. Now, the output is taken across drain terminal, which is made up of metal. So, we will take metal one and we will extend this. Now this output we have to apply to the input terminal of second inverter. So input is the gate terminal, it is made up of the polysilicon. So we have taken the polysilicon, but now but this is not connected because these are two different material. So here there is a contact metal poly. So we have to select this and we have to place on this. So now it is get connected. Similarly, the output of the second is given as a input to the first. So output of the second inverter is given as a input to the first inverter. Okay, so we will place this. Now these are not connected. Okay, if you place the contacts, metal poly contact, then it is get connected. So we have connected this. Now again, if you see the circuit, what we need, where is that circuit? Okay, so what we need to connect. Again we will connect the source of both MOS and source of NMOS together. So for example, if you take these two are the source terminal, again it is made up of metal one. So we will take the metal one and we will connect these together. Okay, so both source terminal we will connect together and we will apply the VDD to this. Again, source terminal of both NMOS we have to connect together and we will apply the VSS, that is the ground. Okay, we will take the ground and we will apply over here. So this is the metal. Now next we have to again take two NMOS to apply the bit line and word line. Okay, so we have taken one NMOS. We can just copy this MOS and here we will get the another MOSFET. Now what we have to do? We have to connect the gate terminal of both the MOSFET together. So what we will do? We will take the polysilicon and we will connect the gate terminal together. So we will take the polysilicon material and we will connect gate terminal together. Okay, so I will extend this. Then think this I will this is we have connected to gate terminal together. Now again what is the our circuit we will actually connect here. We need this one is somewhat at the lower side. I will copy this once again. Now again I will connect with the polysilicon. Okay, then I will do this also just to make the alignments proper. Now if you see again the circuit, the source is connected to the bit line and bit line bar, and drain is connected to the output. Okay, so what we will do, we will connect the drain to the output. Okay, so we will connect the drain to the, suppose this one is the drain terminal, we will connect to the output. Okay, and this will suppose the another drain terminal, we will connect to this output. Again now to the source terminal we have to apply the bit line and bit line bar. So what we will do, we will take one clock signal. Now clock signal we will apply to this bit line. Okay, so here we will give the name as bit line BL, we will assign, and now here we will assign the bit line bar. Okay, so what we will do, we will again take the clock signal and place over here, and we need here bit line bar, so we will just invert this, and now we don't need this bit line bar in the simulation, so we will click on not in simulation, and the we will assign the bit line bar. Again we need the word line, another clock, so we will take the word line and we will place here, and here we will get the input as WL, and we will assign this. Then again what we will need, we have to observe the output. So visible node I will put over here cube as a cube, so this will be the visible node Q we will assign here, and the another node we will placed on this over here. आप इसको Q bar करके दे सकते हो, but again we don't need, so we will click on the not visible in simulation. Then we will save this circuit. Okay, and then we will run the simulation. So here we will get the output. Now observe that. So this is the word line and this one is the bit line. Okay, and here we will get the output. Okay, so this is about the simulation of the SRAM using MIcrowind.